Today in this video lecture, we will see research-based topic on 3D printing, how it works, concrete design. What is 3D construction printing? 3D concreting. 3D construction printing refers to various technologies that uses 3D printing as a core method to fabricate building construction components such as small pedestrian bridges, walls and precast elements. So by using this 3D printing method, we are able to cast these buildings and bridges, small buildings and small bridges. Most precisely, 3D printing is layer by layer deposition of materials without traditional formwork. It uses robotic system to guide print head along a program path. This is robotic system and print head, and this method is using by the help of program path. And this is this is figure 1. This is layer by layer deposition of materials. 3D printable concrete is specifically formulated to exhibit suitable rheology, buildability, and strength development. Benefits of this 3D printing method is geometric freedom, reduced labor cost, and increased material efficiency. 3D construction printing process. Process of this 3D printing construction is: first is preparation of computer-aided design of a structure and its conversion in STL format. First, we have to prepare CAD model and then convert this CAD model in STL format. And what is STL format? STL format is stereological format, describe only surface geometry without any color, texture or common CAD model attributes. Then slicing of this STL format in 2D 2.5D STL format. Then next step is conversion of 2D STL format in machine language, and this machine language is G-code creation for 3D printer to print the structure. G-code file is precise set of instructions that guide 3D printers movements, layering and extrusion, ultimately resulting in a 3D printing object. Next step is intermediate material stage. In this stage, selection and preparation of printable materials, mixed design proportion, batching of materials and proportion of printable mix. Final stage is to command the printer for printing, to control the printer and printing process as per requirement. Design comparison. See, in our conventional concrete, we use binder, water, fine aggregate, coarse aggregate and air content with the help of mixed design. And in 3D printable concrete, observe there is no coarse aggregate in this 3D printable concrete. Only binder, water, fine aggregate and air content are available. And in self compacted concrete, we use binder, water, fine aggregate, coarse aggregate and air content. So in conventional concrete, we use more coarse aggregate as compared to cell compacted concrete, and in 3D printable concrete there is no coarse aggregate. In 3D printable concrete there are more fine aggregates, and binder is also more as compared to conventional concrete. Next, types of 3D printing. First type is extrusion based 3D printing, second type is powder based 3D printing, third type is aggregate based 3D printing, and fourth type is sorted based 3D printing. We will see these 3D printing types thoroughly in our next slides. First is extrusion based 3D printing. In extrusion based 3D printing, uses robotic arm system to guide print head along a program path. This is robotic arm and nozzle, and this robotic arm work with the help of program path. Setup include concrete mixer, screw pump and print head and robotic arm. This is concrete mixer, this is print head and this is pump. So there are four main types. Primary mixing of dry materials and water in mixture. Here mixing of dry material and water is occurs. Pumping of fresh mix through a pump head. See this pump head. By this pump head, this machine pumps fresh mix. And optional secondary mixing at the nozzle to accelerate hydration. Scientists reported print head ultra high performance concrete with compressive strength exceeding 150 MPa. This method supports both on-site construction and off-site prefabrication with printed elements assembled in situ. So, by this method, we are able to achieve 150 MPa compressive strength by this extrusion-based 3D printing method. This is one example of extrusion-based 3D printing method. See this figure 3. This is India first 3D printed pedestrian bridge, IIT Hyderabad campus. India first 3D printed bridge deployed on a campus of IIT Hyderabad. Construction using extrusion-based 3D printing technology. Span of this bridge is 7.5 meter, and this bridge designed with minimum use of concrete and reinforcement. That means this is they optimize this bridge with the help of minimum concrete and reinforcement. And rheology, that means flow and deformation of materials. Rheology requirement for printable material is high yield stress, adequate thick geography, and that means adequate viscous material. So for this 3D printed bridge material, requirement is adequate viscous material. And see this figure 4. They use fiber reinforcement scheme in this IIT Hyderabad pedestrian bridge. This is stress analysis. This figure 6 is geometrical shapes. This is below part of this bridge, and this figure 7 is on-site arrangement. Various geometrical shapes checked by stress analysis and compressed arch geometry shapes selected. See, by the help of FEM software, finite element method software, they check various geometrical shapes. They stress analysis various geometrical shapes and selected compressed arch geometry. Why they selected compressed arch geometry? Because this method only gives high compressive stress. Fiber reinforcement used incorporating short fibers directly into the concrete means to improve tensile strength and ductility. See, in this method, in this extrusion based 3D printing method, we can't use reinforcing rebars directly into concrete. So we can't able to achieve tensile strength. That's why they provide fiber reinforcement to achieve tensile strength. And this is one disadvantage of this method. We are not able to achieve tensile strength. Deposit more material on highly stressed parts and minimum material on less stressed parts. Second example of extrusion based 3D printing method is India 3D printed post office. This 3D printed post office is in Bengaluru, and this is located in Cambridge layout in East Bengaluru. It was built using 3D printing technology by L&T Construction with structural design assistance from the IIT Madras. See, in this 3D printing, we don't have codes now. So they assist the structural design by IIT Madras. The construction was originally scheduled to be completed in 45 days, but it was finished just in 43 days. See, so we require less time to construct this. This is advantages. Less time required to construct this 3D printing post office by using this 3D printed concrete technology. The adoption of 3D printing technology resulted in a cost saving of 30 to 40% compared to conventional construction method. It also allows more flexibility in shapes of the building. So the post office has a built-up area of 1000 square foot, and the post office inaugurated on 18 August 2023. So next method of 3D printing construction is powder-based 3D printing. See machine of this powder-based 3D printing shown in figure 10, and in figure 11, bridge segment printed outcome with a powder-based technique. additive manufacturing technique that involves the selective deposition of a water-based binder to combine granular material layer by layer. So, see, water-based binder they use in this method, and selective deposition of granular materials layer by layer. Production of geometrically complex and highly precise components we are able to achieve by this method, and roller printed assembly spreading an initial powder layer across the built platform. So they use powder type granular material and bind this material by the use of water based binder. Roller printed assembly spreading an initial powder layer across the built platform. So this is roller printed assembly. Pressed powder layer evenly distributed and level according to specified layer thickness. So see this figure 12, schematic illustration of the powder based 3D printing. Binder is dispensed from the printed and precisely deposited onto targeted regions of the powder layer to initiate particle bonding. So this is binder feeder, printed this powder bed and build plate. The process is repeated layer by layer until the object is fully formed. Powder based method used for producing small to medium scale precast elements such as decorative panels and interior elements. So by this powder based method we are only able to cast small elements like precast element and decorative panels. Ability to produce fine geometries and detailed surface textures. See, compressive strength we only achieve up to 30 MPa, and extrusion based 3D printing method is 150 MPa. So limitation of this method is offset construction. Next is example is steel fiber reinforced concrete arch bridge. Construction using powder based 3D printing. This figure 13 shows powder based 3D printing bridge in Spain. First they cast this segment by using this method, and then they arrange this as a bridge. Arch bridge measuring 12 meter in length and 1.75 meter in width. That means length of this bridge, span of this bridge is 12 meter and width is 1.75 meter. Only pedestrian bridge. Due to size constraint of the 3D printer, 2 meter by 2 meter by 2 meter, the overall design and the assembly approach were significantly influenced. So, due to size of this printer, this width is restricted 1.75 meter. They use Portland cement reinforced with 1.3% by volume of this bridge, and reinforced is steel microfibers 13 meter in length and 13 mm in length and 0.15 mm in diameter to control cracking. Curved steel frame was employed to support the prefabricated elements. So see, to support this prefabricated element, they use curved steel support. Before transportation and on-site assembly, the segments were cured until the compressive strength exceeded 25 MPa. So, curing is done for 28 days to achieve 25 MPa compressive strength. In the absence of established design codes, I already tell you that no design codes available for 3D concrete technology. In the absence of design codes, the long-term performance data, a curved steel frame was embedded as a redundant load-bearing system, despite not being structurally required. So, what is redundant loads? See, read again this statement. In the absence of established design codes and long-term performance data, a curved steel frame was embedded as a redundant load-bearing system. Redundant loads refers to alternate backup routes within a structural system designed to carry forces if preliminary component fails. Next type is knitted formwork socket. Next example is knitted formwork socket printed bridge. See, with the help of 12 mm nozzle, first see Next method of 3D printing construction is shotcrete 3D printing method. In shotcrete 3D printing method, robotic arm integrated with the shotcrete delivery unit. See this figure B, specimen production, and figure A, laboratory setup. This process involves mixing dry cementinous materials with water in a conventional mixture and transferring a fresh mixture through screw pump. From there, flexible rubber hose conveys the wet concrete to a robotic nozzle mounted on a robotic arm, enabling high precision spraying. So in this method, they spray this concrete, and this is flowable material is accelerated by compressed air with liquid chemical admixture such as set accelerator are injected into air stream with a dosing pump to ensure precise control. And this is the example of shotcrete 3D printing. This is this is assembly 3D knitted textile former, final demonstrated after fabrication. And thickness of this bridge is varying 30 mm to 100 mm, and layer thickness varied according to structural demands to issue material efficiency, and the flow properties were adjusted between structural and finishing layers to balance strength and structural quality. See, distresses in 3D printing concrete, development of cracks at the corner of a fresh printing concrete wall, and cracks due to early age shrinkage in concrete 3D printing elements. And advantages of this method is faster construction, lower labor cost, reduced material waste, and disadvantages are structural and code challenges, reinforcement issues, and skill technical expertise required. Thank you very much.